Let's look at the correlation to our previous question on differentiation in practice. Here is the derivative of sum. As you can see, we are doing it using an addition. So now, what do we know? We know that from the general rule, if we have something like this, a raised to power n, and I ask to find the y over the s. Now, what is going to happen? Sorry, as raised to power n. If you ask to find the y over the s of this expression, you're going to use the n, which is the power, and multiply by the base, which you have as what? As. And then the power, you subtract 1 from it. For instance, if you have to differentiate the y over the s of 2s raised to power, let's say 3. Just like we have here, a represents 2, s is still there, and n represents this 3. 3 represents the power. So now we are going to bring 3 down and multiply by 2s, and then the power, we are going to subtract 1 from it. You see it is the same thing. Now, once I use 3 and multiply by 2s, I'm going to have 6s. And if I subtract 1 from 3, I'm going to have it to be what? 2. Now, this is my what? Final answer. Note that the s is still with it. All right. So having known this, let's go on to solving this expression here. There are two many. The first one, we have 2s cubed plus 3s squared plus 6. Now, in this formula that we are using, this is the general rule. You cannot see something that is called constant. For instance, in this general formula, we don't have 3, we don't have 2, we don't have 1, we don't have 6, we don't have 7. Hence, any constant any number that does not have s is represented as constant, and any constant is 0. So once you have any constant number, is 0. So for instance, this 6 here, you see there is no unknown variable in it. 6 is just on this one, no s attached to it. So 6, if you want to find the y over the s, differentiating, the derivative of a constant is 0. So let's differentiate this from what we know. We are going to use the power from here to multiply by the what? The base. All right? And then the power, we subtract 1 from it. We add it with this power multiplied by the base. That is this 2 multiplied by the base, 2 multiplied by 3s, and then the power we subtract 1 from it. Now, because the derivative of constant is 0, I'll put plus 0. Now, 3 multiplied by 2s is going to give us 6s raised to power 3 minus 1 is 2. Plus, now you see I'm doing it. This s is still here because this 3 is multiplying 2s and bringing down what? It now becomes 6s, and the power remains 3 minus 1 give us 2. This is how it should be. So this I've applied here is what? Differentiation. I've differentiated to result to this. I'm going to add it with this one. 2 multiplied by 3s, you're going to give you what? 6s. And then in this power, I have 2 minus 1. 2 minus 1 is going to give me what? It's going to give me 1. I get it. But s raised to power 1, s alone just shows that there is what? S raised to power 1. You get? S just represents a power 1. So because of that, we may not represent this power 1 here. We may clean it and write plus 0. Now, if all of this plus 0, we are still going to have what? So this is the answer. Hope you understand. Understood. So now, having known this, let's go over to this second question. This second question says, find the derivative of 4s plus 100. Like I said, the derivative of a constant, this is 100. It does not have s, even 1 million. The derivative of 1 million is 0. You get? So here, this is having s. What do we need to do? This is equals to, this s, like it said here, has invisible power of 1. Now, that's invisible power of 1. We are going to multiply with 4s to give us 1.4. Sorry, this point being multiplied by 4s raised to the power 1 minus 1, because it has invisible power of 1. And according to the rule, we must minus 1 from that power. So we are minusing 1 from the visible power, which is what? 1. And then we are adding it to this 100, which derivative is what? 0, a constant number. All right. Now, going furthermore, 1 multiplied by 4 is going to give us what? 4s. And from the power, 1 minus 1 is going to give us 0. You understand? Plus 0 is still going to give us. Now, coming to this place, any number raised to power 0 from the law of indices is 0. Sorry, is 1. For instance, we have that if a raised to power 0 is equals to what? 1. If 1000 raised to power 0 is equals to 1. Any number at all, anything at all that is raised to power 0, it is equals to what? 1. So because of that, we have that s is raised to power 0. This s being raised to power 0 means that 4 now is going to multiply by what? 1. Because anything raised to power 0 is 1. So s raised to power 0 is what? 1. Now 4 multiplied by 1, which is going to give us what? 4. So 4 is the answer for this second question by derivative of sum. All right, so let's go to the third one. The third one says the find the derivative of 16x squared plus x squared plus 3. All right, like we know, we are now going to be a bit fast so that 2 here, the power used to multiply the base, 2 multiplied by 16 is going to give us what? 32. 32s. Now 2, you minus 1 from it, which is going to give us what? 1. And s raised to power 1 is still what? S. So we not put it. Plus this one now, this is x squared. This x squared now, this 2 is going to multiply by the base. You're going to use the power multiplied by the base, which is going to give us what? 2s. And now the power, you subtract 1 from it. This is this one. It will give you what? 1. You understood? And s raised to power 1 is still what? S. We should not waste our time by adding this one because it's still going to be 0. And if we add this to 0, it's still going to give us what? This expression. And hence, this is our final answer. Right? But furthermore, you can still simplify because that is 2s and plus 2s. They are the same thing. So 36s plus 2s. 2s plus 36 is going to give us what? 38. 38 what? S. That is the final answer because these two are the same thing. Assuming that this is s cubed and this is s squared, we don't add it together. Also, if this was s squared and x squared, we will do what? Add it together. But once their powers of the unknown variable are not the same, just like if this was square and this is just s, they are not going to add it together. But since they are just ss, that means 32 something, let's say 32 biscuits plus 2 biscuits, so they are the same thing, you're going to give us 38 what? Biscuits. You understood? So that is it. Now we move to the next question, which is question number 4. So I might make mistake maybe from solving this one. Maybe we have resulted to okay, we can result to that. Let's continue. Question number 4. So we have 19 plus x squared plus x. All right. Now, like we already know, this is a constant. So the derivative of constant is 0. So we don't have to talk about it. So we just have to what? Bring down these 2 to multiply by what? S. And the 2 we subtract what? 1 from it. And then from here, S, like we already know, has invisible power of 1. Now that power of 1 multiplied by the S and the power minus 1 from it, which is invisible. Understood? So here, 2 multiplied by S is going to give us 2s raised to power 2 minus 1 is going to give us what? 1. But s raised to power 1 just s, so we don't put it. Now you have plus 1 multiplied by s raised to power 1 minus 1 is s raised to power 0. Plus 1 minus 1 is what? 0. Now anything raised to power 0 is 1. So we have 2s plus 1 multiplied by s raised to power 0 is 1. Anything raised to power 0 is 1. So 1 multiplied by 1 is 1. So we have 2s plus 1 at the final answer. Now look at something. Do you know why I didn't call this a constant? Because I said that any constant number is 0. Do you know why I didn't write 0? Because this is the result gotten from differentiating. So after we differentiate, we got an answer of 1. Once one or once a constant number is with the derivative of that expression, you don't call it a constant. It is now your answer. So you don't need to come and say that this here is 0, and hence this plus this, you will not add it together more. So you still add it because this is what we got from differentiating. Assuming it was from the question initially that we differentiated, and then we call it what? 0. Now, if we should differentiate this again, we can still differentiate this. All right. So let's say we want to find the y over the x of this same answer we got from this other one. It will now become the 2y over the 2x because we are differentiating it the second time after differentiating it the first time and get this answer. The second time now we have to differentiate and call it the 2y over the 2x, or you can call it f prime if you're on a higher level. You get. So now differentiating this again, we found out that this is going to give us s here having inverse power of 1 minus 1, and that one coming out by 2x is going to give us what? 2x, and then 1 minus 1 is what? 0, plus what? This is a constant. You will not call it what? 0, because I want to differentiate it again. Now, s raised to the power 0, like any one of the power 0 is 1. 2 divided by that 1 is going to give us what? 1. So it's going to give us, sorry, so the derivative of this expression second time is going to give you what? 2. But this first one is going to give you this. All right. So let's move over to question number 3. So with this, I hope you can be able to know what we're doing. So we have 6 plus 9 plus 8. All right. So find the y over the x of this. That is differentiate this. So all we have here is constant. You get. So you cannot say that when you differentiated, you're going to have 0 plus 0 plus 0, and this will finally be your what answer. You could either add this together because they are the same numbers, they are the same variables in constant. So they are all constant. You can add it together and then all of them result to what? 0. Or you can still do it this way and then you notice that 0 plus 0 plus 0 is what? 0. So differentiating this expression will give you what? 0, and not leaving it in this form. This is the right form. All right, so we move to question number 6. Question number 6 says differentiate 2x raised to power 2. So pause this video, see if you can do this. All right, so what we need to do, the power we use and multiply by the base, 2 multiplied by 2x, and the power we subtract 1 from it. And here we're going to have 4s raised to power 1. S raised to power 1 is representing s, and this is our final answer. All right, so we move to expression number 7. Expression number 7 says find the derivative of 2x cubed. 2x cubed. Now, you're going to use the power multiplied by the base, and the power will subtract 1 from it. So 3 multiplied by 2 is going to give us 1. 6x raised to the power. 3 minus 1 is going to give us 1. 2. That is our differentiation. Okay? Now, I want you to try this. Let me know if you have gotten it. Differentiate t cubed plus t squared plus t. Let me know the answer in the comment section, and let me know the answer in the WhatsApp group. So if you have not yet joined my WhatsApp online class where I got this question from, and we are doing the revision here on YouTube, WhatsApp me on 08153957022. Or if you're in another country, consider adding plus 2, 3, 4. Please share this video so others could benefit. Please share it even on WhatsApp. Share it on WhatsApp. Thank you. Bye bye. See you on my next video.